Hello, my name is Laith. I'm a mechanical engineering student at Virginia Tech. So throughout my time here, I've been exposed to the float problem a lot, especially at NRV. That's where I'm located. So essentially, the process of determining what truck to bring in to repair for final repair, it's a little bit tedious. You have to go through a bunch of paperwork, multiple systems, and try and determine what truck to bring in. And then because our float numbers are so high, we do not have a very efficient method of tracking the trucks. We're using all our overflow lots. They're being parked in slots that are not marked. Basically, it's a real pain to find the truck. Final repair operators spend a lot of time trying to determine what truck to bring in, and then spend even more time trying to find the truck. So the solution I developed here, it's a two-part solution. It's a RFID and a drone. So these are RFID tags. They're super flexible. They can be used in a lot of situations. They are passive tags, meaning that they do not have active power running through them. That's because that gives us the advantage of them having an indefinite lifetime. We can read and write from and to the tag as many times as we want. We don't have to ever worry about replacing them. They're pretty durable. They're weatherproof, and the only way they will not work is if you break one of the connections inside. I tried breaking them. You'd have to deliberately want to break it to not make it work. The second part of the RFID solution is this tablet. So the tablet is essentially, it's an Android tablet. It's custom made. It has a built-in reader and antenna for RFID, so it's a built-in solution. I'm going to show you on the tablet the app I developed for the RFID system. So the app is, you basically run the app. This starts at the final quality gate. This is where they determine, all right, this truck needs to go to repair, or this truck is good to go, and they continue on with their testing. So at the final quality gate, when they deem a truck to need repair, instead of writing it down on a piece of paper or inputting it into Copilot, all you do is you hit new repair, you hit scan, and you scan the tag. Once you scan the tag, you have basically assigned or issued this tag to a truck. Currently you have to manually fill in all the fields, but hopefully in the next couple of weeks I will integrate this into our existing systems. That way you would only have to type in a chassis number or use this built-in barcode scanner to scan the already existing paperwork that have barcodes that we currently use at NRV. There are three main fields here that final repair operators do not use and they should be using. First one is part availability. Part availability for offline repair is different than part availability for production. There are a lot of situations where they bring a truck in, they spend a lot of time trying to determine what truck, and then they spend a lot of time trying to find it. They bring it in, and they do not have parts for offline repair. So part availability is on there. Customer commitment date is another big one. Currently, final repair operators do not take customer commitment dates into account. We have trucks that are really, really late, a couple months, if not more, in our float lot, and they're not being one of the reasons they're not being repaired and sent out is because the operators do not take customer commitment dates into account. The other one is estimated repair time. I'm planning on using another intern's project, Zui. He's planning on using machine learning to estimate repair times. His system will feed my system estimated repair times. Once all the fields are filled out, all you do is you hit save and then you go back. Once you're back, this is where the second part of the solution, the drone, comes in. So you do take inventory, start GPS, start inventory. Once that happens, the reader will get attached to the drone. The drone will autonomously fly over the lot. It's a pre-planned flight path to cover all the lot. It's complete autonomous from takeoff to landing. So these are, like I mentioned, these are ultra-high frequency RFID tags. This gives us a 30-foot read range in altitude and a 25-foot read range, a 25-foot radius. So you do not have to cover You don't have to fly over every truck. You just have to be within that 25-foot radius. Another cool feature is I built into the app is the app will not read the same tag twice, no matter how long you hover or stay near a truck. So you never have to worry about doubling up your inventory or getting multiple hits. Once the drone comes back, the operator needs to make the decision of what truck to bring in. So he goes to all repairs. This is where you see a list of all your repairs, or essentially your float. You can search by repair required. This is important because operators usually know when they get a big shipment of trucks or tires coming in, or a big shipment of drive shafts coming in, and that way they can search for tires and bring in all those trucks. You can also search by estimated repair time. This is helping them to estimate if they have 30 minutes left on their shift, they're not going to start a 3-hour job. You can look for a 20-minute job, a 15-minute job, and get that started, get that done, and get it out of the way before you have to go home. At any point in time with any filter, you can sort by customer commitment date. So let's just say an operator searches for tires, and then he sorts that search result using customer commitment dates and brings in the trucks that we're most late on. Once you decide on what truck you want to bring in, you would go to view inventory. You would search for that specific truck. Obviously, I'm going to look for trucks that are a month late. So I'm just going to go back to June, tell it OK, and search. These are the trucks that I've scanned that are around a month or a month and a half late. This one needs a tire. It's 27 minutes. You decide you want to repair that one, or you search for the truck that you previously decided on. And all you do is you click on it and you give it another tap, and that way Google Maps opens up and it shows you the exact location of the truck, and you can use the tablet as if you're using your phone. You can drive to it, you can walk to it. So ultimately, it's not a tracking software, it's not a scheduling software. It helps the operator make an informed decision as to what truck to bring in, and it also helps him work on his efficiency by finding the truck, knowing where its exact location, and not having to walk or drive around the lot for 45 minutes to an hour to find the truck. It will also help supervisors keep track of their float. If you see a 10-minute repair job and the truck's been sitting in the float for 3 weeks with a very late customer commitment date, then obviously it helps with accountability and it helps with supervising the process. Thank you.